ಮಾಡೋದು ಹೇಳಿಲ್ಲ ನನ್ನ ಕೈಯಿಂದ ಇದು ಅಪ್ಪ ಮಾಡೋದು ಹಂಗೆ
ಮಾಡಿದ್ದೀನಿ. Good morning, everybody. Manoj, unmute yourself and tell me the screen is visible and audible.
Yes, sir.
Okay, thank you. See, last class we discussed about the different materials used for making of pattern. That depends upon number of factors. That is the number of castings required, the dimensional accuracy, and the type of foundry you have, whether the type of mold material, clay, green sand or dry sand. Like that, you have lot of options. According to that, you have to consider number of factors for consideration of different types of material. In the different types of material, we have a lot of material. If number of castings are less, then you go for making of the pattern by using wood. Usually teak wood, seasoned teak wood is used for making of pattern if it is less than 10 or less than 100. Then if you have more than 100 castings, then you can go for making of the pattern with metal. Usually the metals are used for making of pattern are aluminum, brass, and sometimes combination of aluminum and copper. Like that, different materials are used, and plaster of Paris, plastic, and other materials also used for making of casting. The main thing, wax. So the for mechanical engineers, this is very important. All of you seen the statues of god and goddesses and the freedom fighter statues are made by using bronze. See, that type of statues are made by using wax pattern. Wax pattern used in investment casting. The name itself indicates if you pour the liquid molten metal in the molten cavity, wax melts and drops out, flows out, and leaves the mold cavity. Then the mold cavity filled by the liquid metal. So that finally produces a statues of god and goddesses and freedom fighters. Hello, unmute yourself. Next, all of you write down few question papers. You have a question on pattern allowances. That is explained briefly with neat sketch pattern allowances. Now you write down the title. Now you write down the title pattern allowances. Underline that. Underline that pattern allowances. First, come to the point. In sand mold, they all of observe here in the sand mold. First allowance in the mold cavity is draft allowance. Suppose you require rectangular or the prism type of casting. If you make the exact shape or exact rectangular prism, then the lifting of the pattern from the mold cavity, which is a little bit difficult. For that reason, you have to produce, you have to provide the draft allowance in the mold cavity. All of you observe here, the dotted line indicates the shape of the casting. This inclined line indicates the draft allowance. Usually, this draft allowance ranges from 1 to 7 degrees. Remember, you are all mechanical engineers. Suppose if you go to interview in any foundry, the draft allowance in the sand mold, which ranges from 1 to 7 degrees. 1 to 7 degrees. See, if you provide the draft allowance in the mold cavity, you can easily lift the pattern from the sand mold. Then there is no distortion or the shaking of the mold cavity. That's possible. So for that reason, the draft allowance, draft, the name itself indicates draft allowance to provide the small angle in the mold cavity for lifting of the pattern from the mold cavity. Next come to the point B, distortion allowance. Distortion allowance. That is nothing but, as I explained in the last class, say the volume of the metal in liquid condition is more. The volume of the liquid metal is more. When the phase changes from liquid phase to solid phase, the volume contraction takes place. At that time, the mold cavity requires little amount of metal. That little bit of metal can be provided by using riser. Riser works as the governor whenever a mold cavity requires the liquid metal that is supplied by the riser in order to compensate the volume contraction. Say in the distortion allowance, again you have three types. One is machining allowance. See, this is the shape of the casting. The dotted line indicates the shape of the casting. The straight line or thick line indicates the extra metal present on the casting, which is removed after solidification by machining operation, by using grinding operation or shaping operation or milling operation. You remove the extra metal present on the casting. The dotted line indicates the size of the casting and the thick line indicates the machining allowance. The distance between the dotted line and the thick line is machining allowance. This extra metal coming in the casting that is removed by using grinding operation or milling operation or any type of operation, the machining allowance in the mold cavity, that is very, very important. Next come to the point, the shrinkage allowance. As I told you, the volume of the metal in liquid condition is more. As soon as the phase changes from liquid phase to solid phase, the shrinkage of metal takes place. You have to provide the liquid metal to the mold cavity in order to get the exact size of the casting. For that reason, you can provide the shrinkage allowance in the mold cavity. Shrinkage allowance in the mold cavity. All of you observe here, these two arrow mark indicates the extra metal in order to compensate the volume contraction. That is nothing but shrinkage allowance. Next come to the point. Say, suppose you have the casting like this. You cannot remove the pattern by as it is. You require little tapping, little ramming is required on the pattern so that you can easily remove the pattern from the mold cavity. That is called shake allowance. So you cannot remove the pattern in straight or in upward direction as it is. You require little shaking operation, or if you have to shake the pattern in order to remove the pattern from the sand. So for that reason, if you shake the pattern, there will be an enlargement of the mold cavity. For that reason, For that reason, the shake allowance also provided in the mold cavity in order to compensate the shake allowance. Say in the distortion allowance, you have lot of types of allowances. One is machining allowance, shrinkage allowance, shake allowance. Next, come to the point. This is the first one, draft allowance. Second one, distortion allowance. Here, all of you observe here. This is the casting required. I shape of casting required. Okay, if you need the same type of casting, you have to provide some allowances in the mold cavity. In the mold cavity, if you provide the distortion allowance like this for requirement of a straight line on the casting eye section, if you provide little bit of waviness or curved shape on the top or the convex or concave shape on the eye section, which compensate the distortion of the mold cavity, that can be used while producing the eye section of castings. Eye section of castings. So this is a very important. Many question paper, you have the question on pattern allowances. Now, all of you please write down the rough diagram pattern allowances one by one. First one, draft allowance. Second one, distortion allowance. Number 3, machining allowance. Number 4, shrinkage allowance. Number 5, shake allowance. Write down the rough diagram.
ಸರ್ ಅಲ್ಲಿ ವೇಟ್ ಮಾಡ್ತಿದ್ದಾರೆ ಸರ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಲೆಟ್ಟಿಂಗ್ ಮಾಡ್ಕೊಳಕ್ಕೆ.
ಅಲ್ಲಮ್ಮ ನಾನು ಕೊಟ್ಟೇ ಇಲ್ಲಲೋ, ಆಟೋ ಅಡ್ಮಿಷನ್ ಕೊಟ್ಟಿದ್ದೀನಿ, ಯಾರು ಇಲ್ಲ. ಮತ್ತೆ ಜಾಯ್ನ್ ಆಗಕ್ಕೆ ಕೇಳು.
ಓಕೆ ಸರ್.
Write down the rough diagram. First, you write down the title pattern allowances. Below that, write down the question. Explain briefly with neat sketches. The pattern allowances. Write down one by one. Subdivision A, draft allowance. Subdivision B, distortion allowance. Subdivision C, machining allowance. Subdivision D, shrinkage allowance. Subdivision E, shake allowance. In the fifth one, this is wrapping, RAPPING, wrapping allowance. Write down the rough diagram. Subdivision A, draft allowance. Subdivision B, distortion allowance. Subdivision C, machining allowance. Subdivision D, shrinkage allowance. Subdivision E, shake allowance. Now write down subtitle various pattern allowances and their importance. Put a colon, underline the complete sentence. Various pattern allowances and their importance. Underline the complete sentence. Put a colon and hyphen. Write down the explanation. Write down the explanation. Pattern has the same shape. I repeat, pattern has the same shape as that of the casting, but the dimensions will be generally more than that of the casting. Full stop. This extra dimension from the required value, comma, given on the pattern is called as write down in uppercase letters, is called as allowances. Write down in uppercase letter in inverted commas, allowances. That is the extra dimension provided in the mold cavity. That's called allowances. Underline the word allowances. Write the word in uppercase letter. Keep the word in inverted commas. Underline that. Put a full stop. These allowances need to be given on the pattern. Due to metallurgical and mechanical reasons. Mechanical reasons. Next line, write down the different types of allowances are. Next line, write down one by one. Subdivision A, shrinkage allowance. Subdivision B, draft allowance. Subdivision C, machining allowance. Next one, write down number D, scale and grinding allowance. Last one, subdivision E, distortion allowance. I repeat, subdivision A, shrinkage allowance. Subdivision B, draft allowance. Subdivision C, machining allowance. Subdivision D, scale and grinding allowance. Subdivision E, distortion allowance. See, write all the 5 allowances in the examination and explain with your own sentence. Here you have the explanation for shrinkage allowance. Read the explanation twice, thrice, or 4 times or 5 times. Go through the explanation again and again and close the book and write the shrinkage allowance in your own sentence. Own sentence. Shrinkage allowance is nothing but in order to compensate volume contraction. As I told you earlier, that is the volume of the metal in liquid condition is more when the transformation takes place from liquid phase to solid phase. The volume come to the perfect size and shape. So for that reason, in order to compensate volume contraction, shrinkage allowance is provided in the mold cavity. Next, come to the point, the shrinkage allowance depends upon the ferrous and non-ferrous metals. All of you go through this table. The steel or cast iron. See, in this table, you have steel and cast iron. The allowance, shrinkage allowance, 3 to 5 millimeter for 100 millimeter length of the casting. For example, the shrinkage allowance for cast steel is 3 to 5 millimeter per 100 millimeter of length. In the same way, aluminum and cast iron 3 to 4 millimeter per 100 millimeter length. For cast iron 2 to 3 millimeter per 100 millimeter length of the casting. You write only 3 because for almost all of the casting, almost all the castings are produced using cast steel, cast iron, and aluminium. In the examination, write this table. And in some foundries, they use pattern maker's scale.
Hello.
Maker's scale.
Hello, sir.
Hello.
Hello. ಸರ್ 3 to 5 mm per 100 mm ಅಂತಿದಲ್ಲ ಸರ್, ಅಂದ್ರೆ ಅಷ್ಟು mm ಇಷ್ಟು mm ಅಲೌನ್ಸ್ ಇರುತ್ತಾ ಸರ್ ಅದು?
ಹೌದು. ಈಗ ಒಂದು 3 meters ಲೆಂತ್ ಇದೆ ಅಂತ ಇಟ್ಕೋ, ಸಪೋಸ್.
ಓಕೆ ಸರ್.
3 meters ಅಂತಂದ್ರೆ 3000 millimeter ಆಯ್ತು. ಅವಾಗ ಕ್ಯಾಸ್ಟ್ ಸ್ಟೀಲ್ ಲೆಂತ್ ಅಲ್ಲಿ 3 to 5 millimeter shrinkage allowance ಕೊಡ್ಲೇಬೇಕು. ಇಲ್ಲ ಅಂದ್ರೆ ನಿಮ್ದು ಕ್ಯಾಸ್ಟಿಂಗ್ ಸೈಜೇ ಕಮ್ಮಿ ಆಗ್ಬಿಡುತ್ತೆ. 3 to 5 millimeter per 100 millimeter. 100 millimeter ಲೆಂತ್ ಅಲ್ಲಿ ನೀನು 103 or 105 millimeter ತಗೋಬೇಕು ಲೆಂತ್. ಇಲ್ಲ ಅಂದ್ರೆ ಅದು ಶ್ರಿಂಕೇಜ್ ಅಲವೆನ್ಸ್ ಲೆಂತ್ ಕಮ್ಮಿ ಆಗ್ಬಿಡುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತಾರೆ, ಸಮ್ ಆಫ್ ದ ಫೌಂಡ್ರೀಸ್ ಆರ್ ಯೂಸಿಂಗ್ ಪ್ಯಾಟರ್ನ್ ಮೇಕರ್ ಸ್ಕೇಲ್ ಅಂತ ಇರುತ್ತೆ. ಆ ಸ್ಕೇಲ್ ಸೈಜೇ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ನೀವು 100 millimeter ಅಂದ್ರೆ ಆ ಸ್ಕೇಲ್ ಅಲ್ಲಿ 103 ಅಥವಾ 105 millimeter ಇರುತ್ತೆ. ಅದನ್ನೇ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಪ್ಯಾಟರ್ನ್ ಮೇಕರ್ ಸ್ಕೇಲ್. Next, come to the point, very important for mechanical engineers, the machining allowance. Machining allowance, as I told you earlier, say you cannot produce a smooth surface on the casting. So for that, little bit of machining is required. For that also, some allowances are provided in the mold cavity so that you can machine and you can produce the smooth surface. That is, the machining allowances ranges from, for cast iron 1 to 10 millimeter, and cast steel, that is 3 to 12 millimeter, aluminium and its alloys ranges from 1.5 to 4.5 millimeter, and other non-ferrous metals like brass and bronze, which ranges from 1.5 to 5 millimeter. See, just all of you observe here, the extra metal is coming on the casting is removed by machining operation. This extra metal can be provided in the mold cavity so that you can meshing the surface, you can provide smooth surface on the surface of the casting. Next, scale and grinding allowance. Usually, the scale and grinding allowance is ranges from 0.2 to 3 millimeter. This is very less when it is compared to shrinkage allowance and machining allowance. This depends upon again the type of metal and the type of process and the type of the casting, that is ranges from 0.2 to 3 millimeter. Next, you come to the point, the distortion allowance. As already I explained, while making of I section or flat section, you have to make the shape in the mold cavity like this. And all of you observe here. If you need the size and shape like this, you have to make the mold cavity like that. Finally, you have the casting shape like this. This is called distortion allowance. Distortion allowance. Next, come to the point, distortion allowance. All of you, once again, write down the question. Explain briefly with the neat sketch pattern allowances. So these are the pattern allowances diagram: draft allowance, distortion allowance, machining allowance, shrinkage allowance, and shake allowance. In the examination, suppose you have this question, write down these 5: shrinkage allowance, draft allowance, machining allowance, scale and grinding allowance, and distortion allowance. You have the explanation here. So explanation for shrinkage allowance, explanation for machining allowance, scale and grinding allowance, and distortion allowance. So this is the allowances for making of mold cavity using pattern. Next, come to the point, the classification of pattern. Classification of pattern. All of you write down the title. Write down the title in uppercase letter. Classification of patterns. Classification of patterns. Underline that. Write down in uppercase letter. Classification of patterns. Say the patterns are classified according to the many factors, that is the shape, size, number of castings required, the type of casting process, whether it is sand molding or permanent molding or investment casting or any type of casting required, that is depends upon the type of pattern, and on that basis the patterns are classified. Again, all of you write down the classification of patterns, underline that classification of patterns. Below that, write down patterns are of various types. Write down the explanation. Patterns are of various types, comma, but the selection of a particular type of pattern depends upon number of factors, depends upon number of factors, that is number of factors, that is type of molding process employed, type of molding process employed, comma, type of molding process employed, comma, number of castings required, number of castings required, comma, number of castings required, comma, shape and size of the shape and size of the casting. Shape and size of the casting. Full stop. Shape and size of the casting. Full stop. I repeat, all of you, please write down classification of pattern, underline that, complete sentence, write down the explanation. Patterns are of various types, but the selection of a particular type of pattern depends upon number of factors. That is the type of molding process employed, comma, the number of castings required, comma, shape and size of the casting. Size of the casting. Full stop. We will discuss one by one in the examination. Suppose you have this question in the examination, write minimum 5. Usually this question for 5 marks, you write minimum 5 types of pattern. 5 types of pattern. Say, all of you observe here. First one, single piece pattern. Say, this single piece pattern usually made of wood or aluminium. Made of wood or aluminium. So single piece pattern are commonly used for making of plumber block. All of you see the end of the shaft is supported by bearing plumber block. Bearing plumber block. So that type of solid castings are produced by using single piece pattern. By using single piece pattern. This is the solid pattern made of wood, usually teak wood or aluminium. This is the single piece pattern made of wood or aluminium. Write down the rough diagram of the single piece pattern. Write down the title, single piece pattern. Underline that, put a colon and hyphen. Write down the rough diagram of a single piece pattern. Write down the rough diagram of a single piece pattern. And write down the explanation. Single piece pattern is also called as solid pattern. Solid pattern is made of one piece without any joints. Made of one piece without any joints or loose pieces. Without any joints or loose pieces. Full stop. Used for simple shape and large size casting. Used for simple shape and large size casting. Used for simple shape and large size castings. If the number of castings required or less, then they use single piece pattern. Full stop. Single piece pattern. You can observe here they have provided the draft allowance, shrinkage allowance, and all the allowances in the pattern. And next line right now, single piece pattern is made from, single piece pattern is made from wood, and single piece pattern is made from wood and aluminum alloy. Wood and aluminum alloy. Single piece pattern is made from wood or aluminum alloy. Full stop. I stop at this stage. I will continue in the next class. Now, all of you write your name in the chat box, and all of you unmute yourself and answer roll call. Ashwin MU. All of you
Yes, sir.
unmute yourself and answer roll call. Ashwin MU.
Yes, sir.
Ganesh PM. Ganesh PM. Ganesh PM.
Yes, sir.
Vivekanand.
Ganesh PM, sir.
Okay. Vivekanand.
Present, sir.
Pawan HR.
Present, sir.
Hemant.
Present, sir.
Nishchit.
Present, sir.
Akash.
Present, sir.
Abhilash.
Present, sir.
Pratik.
Present, sir.
Abhiram.
Yes, sir.
Hemant. Chhatrapati Chetu.
Yes, sir.
Krutik.
Sir.
Akshay M. Patil. Dhanush.
Yes, sir.
Vignesh.
Present, sir.
Nanesh. Again you are written. Nanesh.
Yes, sir. Yes, sir.
Najma Khanum.
Yes, sir.
Dawood.
Yes, sir.
Chandan RC.
Yes, sir.
Prathamesh.
Yes, sir.
Nutan.
Present, sir.
Manoj.
Yes, sir.
Shahid. Shashank.
Yes, sir.
Karthik R.
Present, sir.
Ganesh Nayak.
Yes, sir.
Sushanta.
Yes, sir.
Jayant L.
Present, sir.
Aditya J.
Yes, sir.
Harshavardhan.
Present, sir.
Sahana V. Bhagat.
Yes, sir.
Danish.
Yes, sir.
Karthik.
Sir.
Karthik MK.
Yes, sir.
Chetan AB.
Present, sir.
Harsha MR.
Present.
Akash. Atal B.
Yes, sir.
Atal B.
Yes, sir.
Nayaz.
Yes, sir.
Jishan
Yes, sir.
Ahmad.
Yes, sir.
Madhusudan.
Present, sir.
Kumaraswamy. Lohit Kumar.
Hello.
Lohit Kumar.
Sir, he has a problem with his microphone, sir. He
Please
can't
pronounce
able to
your
speak.
name.
Hello.
What's your name?
Sir, my name is Darshan, sir. He told me that he has a problem with the microphone, sir. He not able
Who
to
told
speak,
you?
sir. He only messaged me, sir. He
Who?
has a problem with the microphone, sir. Lohit Kumar, sir.
Lohit. Okay, Pratap. Okay, no problem. Okay,
Yes, sir.
okay. Darshan.
Present, sir.
Manoj. Vignesh.
Present, sir.
Jitendra.
Yes, sir.
Madhusudan.
Present.
Anybody else? Those who missed the attendance, telling the attendance, please pronounce yourself. And all of you, in your DP, put your face or passport size photograph. Don't put the scenery photo or something else. All of you put your passport size photo or your face in the DP so that we can recognize your face. Now I stop at this stage. I will continue in the next class.